Hi everybody, today's lesson is going to cover square roots and cube roots. Before we begin, friendly reminder, you do not need to write down everything, but be sure to jot down important information and at least one example of each type of problem we cover. Remember that you can also utilize your pause, rewind, and fast forward buttons. Pause to jot down important information, rewind to go back and review information again, and fast forward if you think you got it already. But be careful. Be sure you don't miss out on anything important. So let's begin. An exponent. You might want to write this down as an important vocabulary word, bold it, highlight it. An exponent shows us repeated multiplication. An exponent is made up of a base number, and it's also made up of a power, the smaller number above it. The base number is multiplied by 1 and itself. So it's very important you include that it's multiplied by 1 as well, and we'll explain that later. The power, the little number on the top right-hand corner of it, tells you how many times you're going to multiply the base number by 1 and itself. Here are some examples. So I've listed out the exponent first, equal to the expanded form, so what it looks like when you expand it all out with the final answer. And on the right-hand side, what you would actually say when you encounter that exponent. So it's going to go in order. 3 to the 5th power, or to the power of 5, is the base number of 3 and the little power above it, 5. What that looks like expanded is 1 times 3 5 times. So 1 times 3 times 3 times 3 times 3 times 3. In total, there are 5 3s. It's not 5 times 3. It's the 3 multiplied 5 times. So if you look in the calculator, 3 multiplied by itself, 1, 2, 3, 4, and 5, that's 243. The multiplication is just 3 times 5, and that's 15. So there's a big difference there, okay? 3 times 5 is 3 being added 3 times. 3 plus 3 plus 3 plus 3 plus 3 is equal to 15. So multiplication is repeated addition, but exponents is repeated multiplication. So you're going to get a much bigger number with exponents. So be careful there. 3 to the 4th power, or 3 to the power of 4, is next. You have 1 less 3, so you get to 81. 3 to the 3rd power, or 3 to the power of 3, is 1 times 3 times 3 times 3, only 3 times, and you get to 27. The special name that we have in red is 3 cubed. 3 to the 2nd power, or 3 to the power of 2, has a special name as well. It's 3 squared. Okay, so if you think about two-dimensional objects, they have 2 dimensions, they are squared. 3-dimensional objects, like a cube, has 3 dimensions, compared to the square, which only has 2 dimensions. 3 to the 1st power is now just 1 times 3, one time, so that's just 3. 3 to the power of 1. Here's where the 1 gets very important. A lot of times people think that any number to the 0 power is just 0. That's where the 1 steps in. That 1 was there all along. So if it's 3 to the 0 power, it just means that the 1 now is being multiplied by no value. Doesn't mean it's being multiplied by 0. It just means it's not being multiplied by anything. So it stays as 1. Okay, so I repeat, 3 to the 0 power, or any number to the 0 power, just keeps the 1. It's not 0, because there's literally nothing that we are multiplying it by. The 1 just stays put. It doesn't do anything. So something important you want to write down in your notes is that any number, any base number, to the power of 1, or sorry, to the power of 0, my bad, to the power of 0 is equal to 1. Okay, it's kind of counterintuitive. It doesn't kind of make sense in your brain when you think about it really quickly. But when you look at this table here, you'll notice that 1 is the value that's being left over, because there's literally no 3's that it multiplies by, so it stays put. Okay? Now, when we talk about square roots, it's literally the opposite of squaring something. And remember, squaring is to the second power. That was our special name for a base to the second power. So square root is going to be another important vocabulary word. You might want to bold it or highlight it. Remember, important vocabulary words go on the left-hand side of your Cornell notes. A square root will ask you for the original base number when they give you the squared answer. So they're telling you to go backwards. They're saying, hey, here's the answer. What did the base number have to be to get to that answer? To say square roots, you just say the square root of, and then the number. So for example, square root of 9 is equal to 3, because this is the answer inside the square root symbol, this kind of check mark with the box over the 9. That's the square root symbol. So they're saying what number had to multiply by itself 2 times and 1 to get to this answer of 9. And that had to be 3, because 1 times 3 times 3 is 9. So you're working backwards to figure out what that base number should have been. This base number right here. So they're giving you the final answer. You got to work backwards to figure out what the big base number is. The other example is square root of 49. That answer is 7, because 7 squared will get you to that answer. 1 times 7 times 7, 2 times, will get you to the answer of 49, the answer inside the square root symbol. So square and square root are opposites of each other. And that's going to come into play in our next lesson. It's important to note that you cannot take the square root of a negative number. So if there were a negative number inside here, it would be impossible. Why? Because that base number needs to be exactly the same. Okay? If it's 2 positive numbers, positive times positive keeps it a positive. There's no way that number inside could be reached because it's negative. If you had both negative numbers, those negative symbols cancel each other out. Those signs cancel each other out. So it would still get you a positive inside your square root. So only positive times negative will get you that negative inside, because the same signs will cancel each other out. But you still have to have the same signs for both of those numbers. The bases have to match each other. So any square root of a negative number inside is going to be impossible. There's going to be no answer, because those 2 numbers got to match each other. Okay, so let me just show you real quickly. If it were 3 times 3, it would get you to a positive 9. There's no way that those 2 numbers, matching numbers, could get you to a negative. If it were a positive 3 times a negative 3, it would get you to a negative 9. But then the positive and the negative were not matching, right? So if you had 2 negatives, negative 3 times a negative 3 gets you back to a positive. So they got to be different signs in order to get to that negative. But exponent rules tell you that that number each time has to be exactly the same. So those signs got to match each other. So negative square roots, impossible. The last thing we're going to cover is cube roots. So cube roots are the opposites of cubed. You probably already guessed that. Another important vocabulary word you might want to bold or highlight. Cube root asks for the original base number when they give you the cubed answer. So like we said, it's the opposite of cubing something to the 3rd power. Here you say the cube root of whatever that number is. So here are some examples. Notice how the cube root looks like the square root, but it has a miniature 3 on the top left-hand corner. That shows that it's not a square root, it's a cube root. Okay? So we're going to get down to the root of it. Get it? We're going to get down to the root of it, what happened to get to that answer. But instead of finding the square root, we're finding the cube root. So just be aware that it's the 3 on the outside to get to the root of it, the cube root of it. So cube root of 8. We want to find the number that will multiply by itself 3 times to get to 8. So that number is 2. The positive answer is 2. Okay? Because if you put into your calculator, 2 times 2 is 4, and you times another 2, that'll get you to that 8. So that answer is 2. The cube root of 27 is 3, because 3 times 3 is 9, times another 3 is 27. So 3 had to multiply by itself 3 times in order to get to 27. So that's the difference between square root, it's only twice to get to the answer, and cube root is 3 times to get to the answer. Now for cube roots, it is possible to solve for the negative cube root inside. You can do that because if it were a negative base number, it would change the answer at the end. Because a negative times a negative times a negative will get you a negative, which is what you wanted inside. Because a negative times negative, remember they cancel out and become positive. Then you're going to multiply by that last negative. And remember, we wanted 2 different signs in order to get to the negative. Okay? So the square root answer always has to be positive or negative. And then the cube root answer can have a negative on the inside. And then that answer would be negative because those signs would cancel each other out and then they'll work out to a negative at the end. Okay? So that's all we have for this lesson. Be sure to rewatch the video if there's something you wanted to go over. But other than that, I'm going to let you do the problems on your own. Please let me know if you have questions as you work on them. And I will see you in class.